Sessions after lunch break. We have a special plenary session by Dr. Saeed Khan Jadoon on energy. So I would like to invite Dr. Saeed Jadoon, who requires no introduction, to the stage. He is going to present his thoughts on energy sector. Dr. Saab.
अस्सलाम वालेकुम। मैं सोच रहा था कि लोग खाने के आधे घंटे बाद आएंगे, लेकिन बहुत जल्दी आ गए वैसे, माशाल्लाह जी। अस्सलाम वालेकुम। Thank you very much, Imran and SP and ATC and management to give us this opportunity to explain something very little but has a very major impact in our industry. And we like to move step by step, slowly but steadily. So the concept of this Petroleum Club of Pakistan as a think tank was originated long time back, but we wanted to have a little bit formal thing so that people can understand the issues in Pakistan with respect to energy and what is our job, what we should be doing it. So Petroleum Club of Pakistan as a think tank for the energy sector. Next please. So what is the think tank? Everybody know what is the think tank. All over the world, people are using think tank for their policy formulation, for their solution of their problems. Unfortunately, we have too many tanks but little thinking. There's no deficiency of tanks, but there's a lot of deficiency of thinking. So in that relation, we kept it as a think tank so that people can discuss, debate, share their ideas, experience, their knowledge, so that for the future point of view, we should be devising a way forward how to do it. So think tank usually works for companies, organizations, institutions, and for every country. All over the world, people have really great think tanks for their future strategy and things like that. Next, please. So this think tank, Petroleum Club, was founded in 2011 initially. At that time, we were thinking that a lot of students have a problem with their placement, with the internship, their training. At that time, we formulated so that we can help young students, young engineers, geoscientists for the internship and training, because 2011, there was very less attraction from the company for the students coming from very remote areas. So, but originally, laterly, that become we were providing another social networking for the professional experts and leader of the energy sector of Pakistan with diverse background and expertise to focus on a single goal of exploring and developing indigenous resources to make Pakistan self-reliant. So that it originated into this form, but now it become not only a petroleum industry club, it become an energy club. So we will telling you what we are doing next please. Again, but it was reactivated in 2019. So I'm the president of this club and Tahir is the general secretary. This is our team. Next, please. Tahir is the main person basically who is working really day and night to work for this coordination and helping us. And these are the advisory committee we got here. Next, please. And this is the downstream and different group of people are our advisory group. Next, please. What is our vision? What we wanted to have this one? We wanted to have Pakistan a leading country in the energy sector. That is always we have this slogan of how to make Pakistan to an energy sector. And our values. This is the only difference, I believe, with respect to the other think tanks. We believe our people are real values. We have to invest on our people. We have to encourage our people. We have to motivate our people. We have to really guide our people to make their destiny. And that is really missing in Pakistan. Worker has no issue. We have a lot of good worker in Pakistan. The only issue is the leadership. अब यकीन जाने कि फुकदान है, कहाँ आता है leadership का? Worker की कोई कमी नहीं है. Workers are there to sacrifice their blood for you, for the country, for the company. But only the leadership is lacking. That is why every institute is suffering, unfortunately, because of the leader. بدقسمتی یہ ہے کہ جو لیڈر اس وقت ہوتا ہے وہ کہتا ہے دنیا کا بہترین کام تو میں ہی کر رہا ہوں, اس کو خود ریئلائزیشن نہیں ہوتی کہ یار وٹ آئی ایم لوزنگ. جیسے ریزروائر مینجمنٹ میں جب ہم ریزروائر مینجمنٹ کر رہے ہوتے ہیں تو وی تھنک وی آر ڈوئنگ ون آف دا بیسٹ ریزروائر مینجمنٹ. آفٹر 20 ایئر پتہ چلتا ہے یار کیا فضول کام ہم کرتے ہیں, اس کو ایسا کرنا چاہیے تھا. وی شوڈ بی ڈوئنگ ان دیٹ وے, وی شوڈ بی ہیونگ اے بیٹر ریزروائر ریکوری. People are a major area. Research and technology, we wanted and we like to promote our local research and entrepreneurial excellence in relevant field by opting advanced technology. We are, taking steps. We are talking to the universities. We are helping students. We are supervising students. We are, requesting people to do their research. Today, I even met with my colleague from Mehran University, and I told him, please give us some project. Do think about the research. We are here to help you, and whatever we can do, we should be doing it. Next, please. Our mission is the strengthening professionals of the energy sector of Pakistan through power of networking technology. I believe یہ power of جو networking ہے یہ بڑی asset ہے. It is really the best way to collect people, to gather people. And اس کووڈ میں تو ہمیں بہت کچھ سکھا دیا کہ this is really a great power to unite people. Next, please. اب ایمز اینڈ آبجیکٹو کیا ہے؟ ٹو پرووائڈ اٹ از اے نان پروفٹ پلیٹ فارم فار انرجی پروفیشنل آف پاکستان اینڈ لیڈرز اراؤنڈ دی ورلڈ ٹو کولیبریٹ ٹو اچیو اوور ویژن, ٹو پٹ ان پلیس افیکٹو سسٹم فار ڈیولپنگ کمپیٹنسی ان ٹیکنیکل اسکلز ان یوٹیلائزنگ ٹیکنالوجی, پرووائڈ اے اپرچونیٹی ٹو آئیڈینٹیفائی اینڈ پرائورٹائز دی کریٹیکل ایشوز اینڈ سملرلی اسسٹ گورنمنٹ باڈیز. سو ہم ان میں سے 2 کام جو بڑا اچھا کر رہے ہیں انشاءاللہ, اینڈ آئی ول بی ٹیلنگ یو وٹ وی ور ڈوئنگ. نیکسٹ پلیز. Next, human resource development. One is the human resource development. What we wanted to do is the human resource which has been developed to make them more useful, to make them more professional, to make them more active, to make them more proactive so that they can do their jobs. And through seminar, workshops and courses, we are doing like this. Next, please. So this is just, I'm giving you only 3 slides about energy. Why we think we need a think tank in energy sector. Allah has blessed us with a lot of resources. یہ بات کہنے کی نہیں ہے کہ ہر آدمی یہی اٹھ کے کہتا ہے جی ہمارے پاس بڑے ریسورسز ہیں. واقعی ریسورسز ہیں. ہمارا نقصان کیا ہے؟ وی آر مس مینیجنگ اوور ریسورسز. وی آر ناٹ مینیجنگ اوور ریسورسز with best quality, with best practices and in best way. Oil and gas started in Pakistan in 1866 اور امریکہ میں یہ 1859 کو پہلا ویل ڈرل ہوا تھا. تو وی ہیو اے مور دین 100 ایئر اولڈ انڈسٹری آف دس. اور یہ پٹھوار میں ہوا, میاں والی میں پہلا ویل ہمارا ڈرل ہوا تھا 1866 میں کندل کے مقام پہ. We have a lot, all these resources: coal, hydro, solar, wind, nuclear, geothermal, coal bed, and energy from the waste. Unfortunately, we are not doing enough. But we should be doing. Otherwise, we are not importer of now fuel because we are not managing these resources. ایک یہ شعر ہے, یہ میں کافی عرصے سے یہ شعر پڑھ رہا ہوں, یہ بڑا امپارٹنٹ شعر ہے, میرے دل کے بڑے قریب ہے. شوق کمال بھی نہیں اور خوف زوال بھی نہیں ہے. نہ ترقی کرنے کا شوق ہے, نہ گرنے کا فکر ہے. گر گئے تو تب بھی کوئی گل نہیں, اور ترقی کر کے تب بھی کوئی گل نہیں. مطلب وی ڈونٹ ہیو اینی فیلنگ. وی فیل اوکے یار, چڑھ گئے تو ٹھیک ہے, گر گئے تب بھی ٹھیک ہے. تو ہم ایک اس کو میں پازیٹیو دیکھتا ہوں کہ ایک ریزیلینٹ قوم ہے جو چڑھنا بھی نہیں چاہتی اور گرنا بھی نہیں ہے. گرنا بھی چاہتی, اس کو گرنے کا بھی ڈر نہیں ہے اور چڑھنے کا شوق نہیں ہے. تو خدا کے لیے کیپ یور ٹریک اپ, اپنے آپ کو آگے کریں, اپنے آپ کو موو کریں, اپنے آپ کو انکریزنگ ٹرینڈ پہ جائیں. اور زوال کا ہمیں اندیشہ ہونا چاہیے. آج پاکستان کے اندر جو زوال ہم نظر آ رہا ہے وہ بیکاز آف دس ریزن ہے کہ ہمیں کمال کا شوق بھی نہیں ہے کہ وائی وی آر ناٹ موونگ اپ, وائی وی آر ناٹ موونگ پازیٹیولی, وائی وی آر ناٹ ڈوئنگ ہارڈ ورک, وائی وی آر کین ناٹ مینیج آور ریسورسز. ایوری تھنگ از ہیئر. وہ کہتے ہیں نا, 1000 foolish can do differential equation, why you cannot do it. ایک میتھمیٹکس کی بک میں پہلے پیج پہ لکھا ہوا تھا, جے تھامسن کی بک ہے, کیلکولیس میڈ ایزی. اس نے کہا کہ if 1000 foolish can do differential equation, why you cannot do it. if 1000 foolish can do ترقی, why we cannot do it. یار ہم کیوں نہیں کر سکتے؟ لیکن ہمیں شوق کمال بھی نہیں. نیکسٹ پلیز. This is just a historical condition we are producing, what we are producing. آپ یقین جانے انڈیجنس آئل ہم 15% 1866 کا ویل ہے, اور 2023 میں 1 سینچری کے بعد بھی ہم 15% پروڈیوس کر رہے ہیں اپنا آئل, اینڈ اونلی 40% کے قریب ہم گیس کر رہے ہیں. اب یہ جو سرخ نظر آ رہے ہیں LNG, that became a killer for this nation. If we will not produce enough, if we will not do more exploration, if we will not develop the field, we will suffer than anybody else. Because LNG import is really a killing feature. But what to do? We have to improve our resources. Next, please. ये हमारी स्टोरी है कि इस वक्त लास्ट ईयर में हमें कितनी एनर्जी चाहिए थी. ऑयल एंड गैस 68%, इंडिजिनस सप्लाई जो है ऑयल एंड गैस 68% कंट्रीब्यूट कर रहे हैं एनर्जी में. और ये जो लोग सुबह भी बात हो रही ट्रांजिशन की, मैंने एक स्लाइड भूल गया. EIA की जो स्लाइड है उसने कहा कि 2070 में भी 60% के करीब ऑयल की ज़रूरत होगी एंड गैस की जो एनर्जी सेक्टर को पूरा करेगी. सो वी हैव 100 more year इन पाकिस्तान टू गो फॉर फ्री ऑफ फॉसल फ्री. और इम्पोर्ट सप्लाई हमारी 55% है. सो व्हाट इज बिगेस्ट चैलेंज इज हाउ टू रिड्यूस दिस इम्पोर्ट ऑफ. ये हम सबका चैलेंज है. एवरीबॉडी हैज़ टू प्ले हिज रोल. नेक्स्ट प्लीज. अब हम व्हाट वी शुड बी डूइंग. जब हमने ये थिंक टैंक बना रहे थे तो हमें क्या सोचना चाहिए. पहला क्या है, सिट वॉच एंड सफ़र. ठीक है, जो हो रहा है अल्लाह की तरफ से हो रहा है, लेट्स सिट वॉच एंड सफ़र. दूसरा है कि लीव दिस कंट्री एंड आउट. बहुत से लोग हमारे अक्सर पढ़ लिखे ये कहते हैं जी छड्डो जी इस कंट्री नू, अब चलिए यहाँ पे रहने की जगह नहीं है. ऐसी बात नहीं है. दिस इज वन ऑफ द बेस्ट कंट्री. और थर्ड तरीका है कि लोग राइटिंग शुरू करते हैं अपने मीडिया में. और चौथी ऑप्शन है इनिशिएट समथिंग यू कैन डू. इनिशिएट समथिंग, एजुटेट समथिंग positive for this country, for industry, for yourself, for the university, for the students, for the people. Let's start something and we opted this one. जब हमने ये ऑप्ट किया, आप यकीन जाने पाकिस्तान के लोग खूबसूरत लोग हैं. और जब हम when we approach to the people internationally या internationally, आप यकीन जाने they are overwhelmed. उन्होंने कहा we are here to support your idea. Just make it please tomorrow, now. We are with you. Make this as a think tank. We should be utilizing it properly. और लोग हम यहाँ सेमिनार करते हैं. अमेरिका में 3 बजे का टाइम होता है. पीपल आर सिटिंग देयर. कोई कहता है जी मैं ताजद पढ़ के बैठा हूँ, कोई कहता है मैं सुबह की नमाज़ के लिए इंतज़ार करूँ. इतना ये लोगों के अंदर जज्बा है. और हमारे यहाँ पाकिस्तान की इंडस्ट्री के लोग जब भी हमने किसी की बात की यार लेट्स डिस्कस एंड डिबेट, एवरीबडी वाज देयर. तो मुझे यकीन है कि ये हमारी गलती है, लीडर की गलती है कि वी कैन नॉट कलेक्ट आवर पीपल, वी कैन नॉट ब्रिंग आवर पीपल ऑन द सेम प्लेटफॉर्म. दैट इज़ वाई एवरीबडी से यार जी कुछ नहीं हो रहा जी, कोई गल नहीं जी, खैर है जी, होने दो जी, मैं कुछ नहीं कर सकता. वो क्यों नहीं कर सकते हो? यस यू कैन डू इट. उसके बाद व्हाट वी डिड, वी ब्रॉट टुगेदर ऑल द पीपल, वाइज पीपल, एक्सपर्ट, इंडस्ट्री के लोग, लीगल. तो सब लोगों ने हमें लब्बैक का वो हमारे पास जमा हो गए. नेक्स्ट. और फिर सबसे पहला काम हमने क्या किया कि हमने पॉलिसी पे काम करने को शुरू किया. अब ये नेक्स्ट प्लीज़. ये बेसिकली पेट्रोलियम क्लब ऑफ पाकिस्तान के 6 थिंक टैंक हमने बना दिए हैं. इसमें सबसे पहला कि देयर 6 डिफरेंट थिंक टैंक्स हैं. ईच थिंक टैंक है कंप्राइज ऑफ 100 to 250 प्रोफेशनल हैं. और ख़ूबसूरत बात यह है कि हम 5 सालों से चला रहे हैं विदाउट हैविंग एनी ट्रेजरर, विदाउट हैविंग एनी मनी इन आवर बैंक, विदाउट इन्वेस्टिंग एनी मनी. सब अपना टाइम इन्वेस्ट कर रहे हैं, लोगों को जमा कर रहे हैं एंड पीपल आर डूइंग देयर जॉब. इस वक्त हमारे पास तकरीबन 500 के करीब इंटेलेक्चुअल मौजूद हैं. जियो साइंटिस्ट, इंजीनियर, लॉ, लीगल, एवरीबडी. और मैं सो हैप्पी हूँ कि एवरीबडी इज़ कंट्रीब्यूटिंग इन देयर एक्सपर्टीज में. टेक्निकल प्रोफेशनल है. और इस हमारे ग्रुप में मिनिस्टर्स हैं, सेक्रेटरीज हैं, ऑयल कंपनी के लोग हैं, ऑयल कंपनी एग्जेक्टिव्स हैं, लीडर ऑफ द यूनिवर्सिटीज़ हैं, लीडर ऑफ द कंपनीज हैं, मिनिस्टर से लेकर इवन बल्कि हाईएस्ट पोजीशन के लोग भी हमारे पास मौजूद हैं फ्रॉम एवरीवेयर. सो दैट इज़ वाई जब मैं लोगों के कमेंट्स पढ़ता हूँ, मैं क्योंकि आई एम मैनेजिंग इट, मेरा तार कोलीग मैनेज कर रहा होता है, तो हमें खुशी होती है कि 1 बजे भी, रात को 12 बजे शायद जैदी साहब मैसेज कर रहे हो ही इज़ लुकिंग एट आवर थिंग्स एंड ही इज़ रिस्पॉन्डिंग अस. सो दिस इज़ समथिंग गुड. उसके बाद कोल पेट्रोलियम एक्सप्लोरेशन, मिनरल रिसोर्सेज, कोल टेक्नोलॉजी, LNG मैनेजमेंट, पावर एंड UFG, इन सब पे हमने डिबेट किए हैं, सेमिनार किए हैं, वेबिनार किए हैं. और पूरी एक छोटी सी रिपोर्ट बना के मैंने गवर्नमेंट को भी दी है कि ये थिंक टैंक है, ये लोग, एंड गवर्नमेंट आस्क अस नाउ कि आप हमें बताएं. तो ये एक अच्छी बात है कि गवर्नमेंट रियलाइज कि वी नीड ए थिंक टैंक एंड नाउ दे आर रियलाइजिंग कि वी पीपल हु आर डूइंग ए वॉलंटरी जॉब फॉर द गवर्नमेंट, दे आर इनकरेजिंग अस, दे आस्क अस टू प्लीज़ गिव योर कमेंट्स. अभी रिसेंटली जो सुबह जो टाइट गैस की पॉलिसी हुई थी वो हम इस क्लब से ही मांगा गया अपनी राय. اور 2011 میں بھی خوش قسمت ہوں کہ 2011 میں ٹائٹ گلیز پالیسی میں نے بنائی تھی اور اب اس کو امینڈمنٹ میں ہی کر رہا ہوں اپنے گروپ لوگوں کے ساتھ مل کے. تو یہ ایک اچھی چیز ہے, پیپل ریئلائزنگ اٹ. اس کے بعد ہم نے منرل ریسورس پہ بھی ویبینار کیے ہیں. اٹس ریئلی اے گریٹ ویلتھ وی ہیو. لیکن ظلم ہے, میں ایک اور آج کل ایک کام ہم کریں نیشنل اسکل ڈیولپمنٹ پروگرام کے تحت منرلس کے اوپر بڑا زور ہے. پاکستان میں منرل ریسورسز اتنے زیادہ ہیں, آئل اینڈ گیس کے مقابلے میں تو بہت زیادہ ہے, لیکن وی کین ناٹ پرووائڈ ایکسپرٹ مین پاور ٹو دی ایکسپلوریشن کمپنی آف دی منرل. یہ کمال ہے. باہر سے لوگ آتے ہیں کہتے ہیں ہمیں کوئی ایکسپرٹ تو مائننگ کا, ہمارے پاس مائننگ کا ایکسپرٹ کوئی نہیں ہے. باہر سے کوئی کہتے ہیں بھائی پورے, میں مختلف صوبوں میں بات کر رہا ہوں ان کے ہیڈ سے, منرل پالشنگ, منرل کٹنگ یہ کوئی ہے ہی نہیں ہے, ٹرین ہی لوگ نہیں ہے. مائننگ کے لوگ کو ٹرین نہیں ہے. مائننگ کیونکہ اگنورڈ سبجیکٹ رہا ہے اور اس لیے وہ لوگ ڈیولپ, ابھی ہم ایک پروگرام بن رہے ہیں کہ ان لوگوں کو ڈیولپ کیا جائے. اسی طرح کول ٹیکنالوجی کو اللہ ہیز بلیسڈ پاکستان ود ون آف دی ہائیسٹ نمبر آف کول 185 بلین ٹن. لیکن آج 70 سال ہو گئے ہیں, اب کوئی پاور شاور جنریٹ کر رہے ہیں, لیکن انفارچونیٹلی وی آر ناٹ ڈوئنگ انف ٹو ہارنس دس ریسورس. اس پہ ہم نے کام کیا ہے. سی بی ایم پہ, اس پہ ایک اور چیز رہ گئی, سی بی ایم پہ ہم نے کام کیا ہے. اس پہ انشاءاللہ مزید کام کی ریکمنڈیشن جا رہی ہیں. LNG مینجمنٹ از another big challenge for Pakistan. Neither we can predict, neither we can forecast, neither we can buy properly. تو ہم ہر وقت سفرنگ موڈ میں رہتے ہیں, ریئیکٹیو موڈ میں رہتے ہیں. تو کوئی ایسا ادارہ نہیں ہم میں سے کہ جو ہمیں ہماری پریڈکشن کر سکے کہ نیکسٹ 6 منتھ میں کیا ہوگا یا 8 منتھ میں. اس لیے ہمارے LNG کے اوپر مسائل بنے رہتے ہیں. پاور از another biggest problem and UFG unaccounted for gas. پاکستان میں ہر سال تقریباً $600 ملین کے قریب تقریباً گیس اناکاؤنٹڈ ہے. مطلب ایوری نوز, یہ نہیں کہ چھپی چیز ہے. پائپ جا رہے ہیں بھائی, پائپ سے گیس لیک ہو رہی ہے, کسی کو کیوں نہیں پتا کہ پائپ کہاں لیک ہو رہا ہے. اینی وے نیکسٹ پلیز. اب ہم نے ان ساری چیزوں پہ ڈیبیٹ کیا. 2012 کی LNG کی ساری چیزوں پہ ڈیبیٹڈ, اور ہم نے 2 پالیسیز بنا کے گورنمنٹ کو دیے ہیں. پیٹرولیم پالیسی 2012 کی ریفارم دی ہے اور ٹائٹ گیس کی پالیسی دی ہے. اس طرح ڈی ریگولیشن آف پیٹرولیم پروڈکٹس از another big issue in Pakistan. ہر وقت گورنمنٹ مسائل میں رہتی ہے, تیل کی قیمت بڑھائیں یا کم رکھیں, بڑھائیں یا کم رکھیں. بھائی یہ گورنمنٹ کی جاب نہیں ہے یار. لیٹ پیپل ٹو ڈیسائڈ, لیٹ دی مارکیٹ ڈیسائڈ کہاں پہ کیا جائے. پوری دنیا اگر تیل بیچ رہی ہے اور آ رہی ہے تو ہم کیوں ایسا کر رہے ہیں. اسی طرح کول کے اوپر یہ ساری چیزوں پہ ہم نے ڈیبیٹ کیے ہیں, ڈاکومنٹ کر کے گورنمنٹ کو دیے ہیں. نیکسٹ جی, نیکسٹ. اب ایک اور جو بہت اچھا کام یہ کر رہا ہے, جو اس وقت ون آف دی بیسٹ ورک یہ کلب ہمارا کر رہا ہے, کہ ڈیلی پوری دنیا سے پاکستان کی نیوز, آئل, گیس, تمام انرجی کمپوننٹ کے LNG, LPG, کول, پاور کی ہر روز کی نیوز جو ہے نا ایوری باڈی از گیٹنگ, اور اس کے ساتھ کاسٹ بھی بتائی جا رہی ہے, اور ڈیلی انٹرنیشنل نیوز بھی ریلیٹڈ آ رہی ہے. اور یہ ایک بڑا اچھا کام ہے جو مجھے بڑا پسند ہے. لوگ اس کو یوز کرتے ہیں. ایوری ڈے یو ول بی گیٹنگ دس انفارمیشن آن یور ٹیبل, اور یہ کمپلیٹ والنٹری. نیکسٹ جی, یہ نیوز لیٹر ہے جو ہم پبلش کرتے ہیں اس میں. نیکسٹ جی, یہ میری ریکمنڈیشن ہے. دس از دی اونلی ریکمنڈیشن آئی ہیو ٹو یو اینڈ آئی ریکویسٹ یو. جیسے افراد نے کہا تھا نا, شکوائے ظلمتے شب سے کہیں بہتر تھا اپنے حصے کی کوئی شمع جلاتے جاتے. اس کی وہ جانے اسے پاس وفاق تھا کہ نہ تھا, تم فراز اپنی طرف سے تو نبھاتے جاتے. بس آپ سے گزارش ہے آپ اپنی طرف سے نبھائیں, اپنے حصے کا چراغ جلائیں. انشاءاللہ اٹ ول موو. پاکستان کو اللہ پاک ہمیشہ قائم رکھے گا اگر ہم یہ شمع جلاتے رہیں گے. بس ہمارا یہی کام ہے, یہ کام ہے بس, اونلی شمع جلانا. We don't have a solution of your problem, but we like to light this candle in the dark to see some light at the end of the tunnel. Thank you very much. بس جی, بہت شکریہ آپ سب لوگوں کا, آپ کے سننے کا. جس کو بھی کوئی چیز پوچھنی ہو, آئندہ ہمیں کنٹریبیوٹ کرنا ہو, we are here to serve you. Thank you very much. بہت شکریہ.
Thank you very much, Dr. Saab, for a good session. We will be continuing the technical session, Raja.
So, after an energetic and thought-provoking topic being discussed by Sir, it's time to head on towards the session 2 for today. In this session, number of 3 papers will be presented. The companies presenting these papers will be Pakistan Petroleum Limited, Mari Petroleum Company Limited, and Weatherford. Mr. Zaid Ashraf would be heading on towards us as a chairman for today's session. He is currently working as a general manager, reservoir management and development for OGDCL. He holds a master's degree in petroleum engineering from UET Lahore. He has also been associated with oil and gas industry for the last 33 years. Prior to joining OGDCL, Mr. Zaid Ashraf has also served Pakistan Petroleum Engineering Department as lecturer from UET Lahore. He has also been associated with Directorate General Petroleum Concessions, Ministry of Energy. He holds a diverse experience of classical reservoir engineering, pressure transient analysis, artificial lift operations, enhanced oil recoveries, well interventions, reservoir simulation studies, and economic analysis. Mr. Zaid Ashraf, please join us on stage. Mr. Fawzan Iqbal will be joining us as a co-chair for this session. Mr. Fawzan Iqbal is leading United Energy Pakistan's technology initiative to sustain and develop its hydrocarbon portfolio. With his diverse experience in subsurface technical roles, including work at EDCO and BP, he is currently serving as the Senior Manager, Commercial Special Initiatives. He is responsible for the development of renewable energy, including geothermal energy and carbon capture and storage at United Energy Pakistan Limited. Fawzan Iqbal holds a master's degree in petroleum engineering from Harvard University, UK. He is also a graduate from UET Lahore. His experience encompasses various aspects of field development, reservoir management, technology projects, including Brightwater, integrated asset modeling, intelligent and smart completions, hydraulic fracturing, radial jet drilling, and gas well deliquifications. Mr. Fawzan Iqbal, please join us on stage. So the first paper to be presented in this session holds the title, Unlocking Recovery Potential in Mature Clastic Oil Rim Reservoir Using an Integrated Reservoir Simulation Model, a case study in the Eastern Potwar Basin, Pakistan. Paper will be presented by Saad bin Akbar. He is working as the Senior Reservoir Engineer in the Reservoir Modeling Group of Pakistan Petroleum Limited. Mr. Saad bin Akbar, please join us on stage.
Assalamu alaikum. Thank you for joining me today. I am Saad bin Abrar. I have been working at Pakistan Petroleum Limited as a senior reservoir engineer. It's my pleasure to present you our study on unlocking the recovery potential in a clastic oil rim reservoir using integrated reservoir simulation model, a case study of Eastern Potwar Basin of Pakistan. Before we go into the detail, let me give you the roadmap of what we will be exploring today. First, we will discuss the brief introduction of the field, then the standard workflow of model development, then some uncertainties related to petrophysics, geophysics, static modeling, and reservoir engineering. Finally, the results and conclusion of the study. The development of any oil and gas field is a dynamic journey that is filled both with challenges and opportunities. An illustrative example of this is the Sigma field that was discovered in 1970s in the Potwar Basin of Pakistan, and field has been in production since 1990s. The field comprises of two main sandstone reservoirs, X and Y formation, and both reservoirs are producing the similar rich gas condensate fluid. Field has three main compartments. This is the core compartment of the field. This is northeastern compartment, and this is the southeastern compartment of the field. In 2016, an appraisal well was drilled in this southeastern compartment, which led to the discovery of oil rim in the field. So our objective was to unlock the recovery potential of this oil rim. Before we move into the model development, I want to highlight some key challenges that we had during this study. Fluid contacts, or none of the sigma well encountered the free water level, and the gas oil contact is also uncertain in the field. The first well that was drilled in the southeastern compartment encountered the significant reservoir depletion. So which means that the PVT properties that we had was not at the initial reservoir condition. Reservoir heterogeneity, we have experienced significant reservoir heterogeneity in this field. Even within few hundred meters, we have experienced the significant reservoir heterogeneity. As the field lies in the Potohar Basin, and this basin is very tectonically active, that's why the field has very complex faults and structural geometry. This is the standard workflow of development of any reservoir model that consists of several sequential steps, including data collection, conceptual modeling, grid construction, rock properties, fluid properties, initialization, simulation, history matching. All these steps is followed in all the integrated reservoir simulation model. However, in my presentation, I will only focus on this integration part, where each discipline collectively address the uncertainty and improve their understanding by incorporating the inputs from other disciplines. So in upcoming slides, we will discuss this integration part of our study. In petrophysical analysis, the purpose of this study is to determine the most influential parameters that are affecting porosity and water saturation. As we know that the porosity and water saturation are the key parameters in volume estimation. Using all the available log data, multi-control simulation analysis shows that these are the key parameters that are affecting our porosity and water saturation, that are cementing factor, Clay volume cutoff, grain size distribution, and grain density, and the less of the parameters has had less impact on porosity and water saturation. As we have discussed that none of the well encountered the free water level. However, sigma 32, that was the deepest well in sigma field, experienced the water transition behavior. So saturation height modeling was done, and it revealed that the free water level that was previously assumed was 150 to 190 meter deeper. So this new information added the opportunity in oil rim development. As the Potohar Basin is tectonically very active and the structural geometry is very complex, the initial structural model was built with unstructured grading. However, this unstructured grading is not compatible with the previous generation simulator, so we had to explore other options, corner point grading and stair-step grading. Corner point grading is not compatible with low angle thrust sheets, and it's difficult to grade all three compartments in a single model. So this thing left us only one option, stair-step grading. That's what we use in our static modeling. However, the problem with stair-step grading is it generates a stair instead of the fault plane that we have here. Because of this stair-step we had few challenges during our static modeling, like the faults that were closely spaced, the stair of those faults merged together, and stair of the faults that are close to the well introduce the unnecessary zone repetition, as you are seeing in this diagram. This is the unnecessary zone repetition near to the wells. So in order to address these challenges, we have adjusted shape of some of the faults and removed some minor faults from the static model. The initial realization of static modeling revealed that the static in-place volume in core department was significantly lower than the material balance estimates. Several realizations were performed on petrophysical properties distribution. However, all these things did not bridge the gap. So it was advised that to add the low confidence area of core compartment within the model. This thing resulted in increase in 3 to 4 square kilometer area in core compartment, and this thing addressed the discrepancy between static and material balance analysis. The pressure data of all three compartments wells showed that all three compartments are in pressure communication. However, the seismic data was not showing that there is no juxtaposition between northeast and core compartment, as you are seeing in this diagram. So the fault horizon were edited in a way to create the juxtaposition between northeast and core compartment. During our material balance analysis, we had two main challenges. One is, as you are seeing, that significant pressure is scattered in the pressure data, and the overpressure nature of the sigma field. So these two challenges reduce our confidence level in material balance analysis. However, it helps us to determine the range of our low and high in-place connected in-place volume. As we have discussed earlier, that the first well of the southeastern compartment experienced approximately 1000 psi pressure depletion, which means that the oil sample that we had was not at the initial reservoir condition. To address these challenges, we extrapolated the So this orange line is the observed PVT data, and this blue line is the correlation points. So as you are seeing that at higher reservoir pressure, both the correlation and actual data was following the same. So what we did, from the initial reservoir pressure till this point, we used the correlated PVT properties, and from this point to onward, we use the actual PVT data. As all compartments are in pressure communication, therefore single free water level and GOC was assumed throughout the field. The selection of gas oil contact was based on the performance of sigma 14x and sigma 14y. As sigma 14x was producing light condensate of 52 API, and sigma 14y was producing 38 API black oil. So due to the uncertainty in gas oil contact and free water level, as we have discussed earlier, that free water level was based on saturation height modeling. So both these parameters were taken as history match parameter. Based on our history mesh model, we have developed the optimum field recovery plan. This plan had two main objectives. First objective was to reduce the uncertainty in free water level and appraise the field at further level. And the second objective was maximize the net present value of the field. So based on this plan, we have identified 5 potential infill appraisal well location in southeastern compartment. Sigma 5 was proposed as an appraisal well for free water level uncertainty to reduce the uncertainty in free water level. And Sigma 6, 7 and 9 were proposed between Sigma 3 and 5 to recover the remaining hydrocarbon volume in core compartment to maximize the NPV. And Sigma 8 was proposed as a step out well in northeastern compartment to appraise it further. 3 well locations were identified in northeastern compartment, but due to the limited production data in northeastern compartment, these wells were considered as high risk well, and the drilling of the other 2 wells were contingent to the success of the first northeastern well. So the conclusion of the study is, by integrated approach, we have successfully addressed the key challenges like complex geology, fluid contacts, reservoir behavior, and through this integration, we have improved our understanding of the reservoir performance and reduced the uncertainty in JIP estimation. And we use the stepwise approach for the development. This strategy ensures that the efficient reservoir management and in the meantime avoided the unnecessary risk. So my final word for this presentation is, due to the inherent uncertainty associated with the subsurface data, we required the integrated approach so that we can reduce the uncertainty in any field development. I would like to express my thanks to the management of PPL to support me in this study, and all my co-authors who work with me in this study, and the study leader to ensure his constant guide and support so that we can work as a single team. I am telling you, it was the most difficult part of the study.
Floor is open for questions. First question is from my side. What was your base case and optimized case?
So our base case recovery was 500 BCF and our optimized case recovery was 572 BCF.
On what basis you have selected the optimized case?
Optimized case, we have run several sensitivity analysis. We have run even water flooding cases, and all this things were performed, and based on the NPV analysis, we concluded that this is our optimum recovery case.
Okay, floor is open for questions.
Probably a more technology-driven question. You may have used something more innovative, but was there any artificial intelligence, machine learning algorithms used in your study? Because the whole world is turning towards it, and I think that without those technologies, it's going to be increasingly difficult for us to hit useful oil.
Yeah, you have a very good question. We have. I couldn't show all my sensitivity analysis. We have run artificial lift analysis, and I think some of the artificial analysis is being implemented based on this field development plan.
All right. So, any computer vision algorithms, or
No.
Okay.
Not.
So I think probably my advice as a technologist for your next rounds would be to incorporate that. Because maybe used sort of unsupervised learning machine learning models, and I think that can be really instrumental for our oil and energy landscape in Pakistan. But thank you for that.
Thank you for your suggestion.
So may I please request for all the participants going for the questions, please introduce yourself, and if you could stay brief on your question. Thank you. Saad, last question from my side. So to overcome these uncertainties, the approach that you have taken is around the integration part. So were there any limitations why you couldn't go for any additional data set? If you could highlight that part as well.
Sorry, if I move into the... Because of the inherent uncertainty in the, for example, like here you are seeing in this slide, the pressure data was showing that all three compartments are in pressure communication. However, this seismic data was not showing the same thing. So you can't ignore the pressure data. The only option left is to adjust the seismic interpretation in a way that the juxtaposition created between these compartments. So there are some limitation. Even after acquiring so many data, you will still have some uncertainty. And your suggestion is good that we can, where is it possible, we can acquire additional data. But there were some limitation. We have to utilize the available data. Sometimes data acquisition takes so much time. So sometimes you can't acquire the reseismic and reprocessing.
Great. Thank you so much. Thank you, Saad, for your presentation.
Thank you.
So we'll go for the next presentation. And we have the title Smart Well Completions, a comprehensive review of technologies, applications, and challenges. And we have presentation from Mari Petroleum Company Limited. And the presenters are Mudassir Khan, Mohammad Janzeb Ejaz, Imran Shafi, Mateen Haider, and Hewad Ahmed.
Assalamu alaikum. I am Mudassir Khan from Mari Petroleum Company Limited, and today I am here to present a comprehensive review of technologies, applications, and challenges related to smart well completion. And in this presentation, I will shed light on the introduction. After that, I will discuss about the application of smart well completion. And after that, the challenges associated during installation of smart well completion, and followed by the cost analysis and the benefits of smart well completions. So smart well completion is a combination of smart technologies with the conventional completion jewelry equipment. So the objective of the smart well completion to install this completion is to achieve the continuous real-time bottom hole reservoir data, and to maintain the optimum production, and to get the efficient reservoir management, and to get the commingled production from different producing layers of the reservoirs. There are different components that are similar to conventional completion, but there are three major components that are specifically added with the smart well completion. The first component is the permanent downhole gauges, which is required to continuously monitor the downhole data. Second one is the ICDs and ICVs, which are the control valves installed in the tail of the completion string. And third one is the feed-through packer. These packers function similar to the conventional completions, but they allow the provision for the control lines to pass through it without compromising the integrity of the packer. And these control lines are used to open or close the control valves that is installed below it. So basically there are two types of control valves. First one is the ICDs, inflow control device, and next one is the inflow control valve. So ICD is the prior technology before the ICVs. So it is basically used to balance the production from producing commingly from different zones, due to which this valve is installed against the formation, which is used to choke back the high producing reservoir to get the optimum commingled production from the well bore. And by choking back the high producing reservoir, we can delay the water and gas breakthrough, and also minimize the water cut by restricting the high producing formation, water producing formation. So, in this type of ICD, nozzle type ICD is commonly used. Nozzles are installed in the valve, and the desired pressure drop is achieved across these nozzles to get the optimum production. Next type of ICD is the autonomous inflow control device. It automatically controls, allows the desired fluid from the formation and restrict the flow of unwanted fluid from the reservoir like water. So, this AICD has further two types, which is viscosity type AICD and density type AICD. Viscosity type AICD segregates the fluid on the basis of viscosity, so that the desired fluid from the formation of specific viscosity is allowed to pass and produce to the surface and restrict the undesired fluid. But in the case of lateral oil, where the viscosity of oil and water become very much similar, so for that type of reservoir, we used density type AICD, which allows the fluid and segregate the fluid on the basis of their densities. Next one is the inflow control valves. These control valves are used to control the production from each layer individually. Basically, it opens at different positions so that we can adjust the bottom hole pressure according to the from the start initial life to the late life of the reservoir. There are three types of inflow control valves based on the number of control lines operated by them. So, first one is the direct hydraulics, and the number of control lines are based on the formula of n+1, where n is the number of ICVs and +1 is the one common closing line to close all the ICVs at a time. So, number of ICVs mainly depend on the number of producing zone, one ICV for each zone. Next one is the digital hydraulics. It uses only 3 control lines, and from these 3 control lines we can control the 6 ICVs. And these control lines, in which the 2 control lines are pressurized and 1 control line is unpressurized. And this is type of ICV based on the binary code system, worked on the binary code system, where the pressurized control line named as 1 and unpressurized control line named as 0. So, on the combination of 1 and 0s, these 6 ICVs can be controlled. And third one is the all electric ICVs, and this is operated electrically. On only one electric line is required to operate the maximum ICVs, and this electric line can operate 24 ICVs at a time in a well bore. So, going towards the application of the smart well completion, firstly, smart well completion is used in the multi-layer reservoirs. Zahrani et al. Presented a case study of an oil field of Saudi Arabia to implement the smart well completion in the wellbore. First, the main objective behind the case study was to get the commingle production from different layers, and total 5 layers were present in that wellbore. So, the objective was to install the smart well completion. So, the methodology was that smart well completion was drilling in hole with 12 permanent downhole gauges. 2 gauges for each zone and 2 gauges were installed at the top of the topmost packer to get the flow rate and the pressure values on the upper completion. And 5 ICVs were installed, 1 ICV for each layer, and each ICV is separated by a production packer. And at the end, 7 control lines were run with each ICVs and 1 for closing the ICVs. And at the end, the tubing hanger was let in, and all the production packer was set simultaneously. So, in this time, because all the completion assemblies were already assembled at the surface, so 120 rig hours time was saved due to efficient planning and pre-assembled assemblies. And it also improves the oil recovery and also get the maximum oil recovery from 5 different layers, and also reduce the required number of wells. Next is the commingled production from the reservoir. So, for this purpose, Pari et al. Presented a case study, simulation-based case study basically, of an Australian oil field, in which the comparison was drawn with of the smart well completion with the conventional completion. So, here we can see that the purple line on the graph is showing the trend of the cumulative oil production of the field from the conventional completion, and the upper line, which is the almost dark blue line is showing the cumulative oil production from the smart well completions. And similarly, the black line showing the to cumulative water production from the smart well completion, and the red line showing the water production from the smart well completion. And at this point where the arrow is mentioned, we can see that as the production limit is approached to our set limit, ICV is operated in the smart well completion and choke back the high producing layer, due to which the water production is reduced and the cumulative oil production of the field is increased. And for this the result, total 7 wells were present in that field, out of 3 were considered for the smart well completions. And in this process, we cumulatively got 0.8% higher ultimate oil recovery from the field by installing the smart well completion on only 3 wells. And water production was also controlled, and total NPV of the project was positive. Next one is the production from the marginal fields. So for this purpose, Afolabi presented a case study of a marginal field of Nigeria. In this, the main objective was to optimize the economics and to minimize the number of wells to get the optimum recovery from the marginal field. For this purpose, smart well completion was selected to be implemented in this well bore to get the commingled production from both zones. As you can see in the graph, that the first layer is low producing and only producing 500 barrels of oil per day, and the second layer is relatively higher producing and producing almost 2500 barrels per day. So by applying the smart well completion, both zones were producing commingled, and the total production rate was achieved 3000 barrels of oil per day. Next one is the auto gas lift. Auto gas lift is a very important application of smart well completion. In this application can only be applied on the reservoir overlaying with a gas cap reservoir. So NG et al. Presented a case study where 3 cases were developed. First case was where the no auto gas lift and no ICV, means simple conventional completion was done. Second one is where the author presented that auto gas lift valve was installed in the gas cap against the gas cap zone, and the ICV was installed against the oil zone. And third one is that only gas lift valve was installed and no ICV was selected. And the cases were presented, compared for all 3 cases, and we can see that the cumulative oil comparison, 13.5% higher recovery was achieved for the case 2, where the auto gas lift was installed with the ICVs to control the production, to get the control production of the oil zone and avoid the gas and water breakthrough. And in other graph, we can see that in water cut comparison, a huge water cut was observed for case 2, because the oil production was controlled, and similarly the gas cut was also reduced. Next one is the challenge. Also, there are many applications of smart well completion, but still there are many challenges associated with the smart well completion, either in the designing phase or in the operation phase. In designing phase, the major problem was the first problem was encountered is the candidate selection. So candidate selection is very important, so that after the implementation of smart well completion, we get the desired objectives and get the positive impact of the project on the NPVs. Second one is the managing the commingled production with high pressure, having the high pressure differential. So it is also a very challenging to design a such control valves which can manage or choke back the high producing formation and get the optimum commingled production. Next one, related to operation, next one is the space out challenge. As the multiple packers are set and isolated, so space out becomes a very challenging. Similarly, torque and drag issues are also encountered, and handling of multiple control lines, because there are multiple control lines to control the multiple ICVs. So the cost analysis is also carried out between the conventional completion and smart well completion. As we can see that in smart well completion, we already getting the real time bottom hole data, so we don't need the well intervention. So the cumulative cost of Cumulative cost of the LLIs and the well intervention for 5 years of well life for over 1000 meter well is 900,000 USD, and as compared to that we have only 800,000 USD dollar for a smart well completion. So the benefits of the smart well completion is that we get the real-time data to control and optimize the production, and we can efficiently manage the reservoir, managing the water cut efficiently and gas breakthrough, and we can successfully deploy the optimum depletion strategy of the reservoir. We can get the commingled production by using the smart well completion without having any problem, and we and from this, by using this technology, we can also add result from the marginal zones which are not economical if you are producing separately. The installation of smart well completion also eradicate the need of the well intervention, so we don't need to intervene into the well bore. We also don't need the production logging, and we can get the production from multiple zones without intervention, doing early intervention into the well bore. And third one, we can, it is very helpful in the remote areas, security sensitive areas, where we cannot frequently visit and to get the data, required data, and do the well intervention. So it is very helpful in those areas, and it is also reduces the number of wells to get the multiple production from a same well bore, and it also keep the waste underground. It also minimize the water cut so that the formation water cannot be produced on the surface. And considering all the benefits and the application of the smart well completion, MPCL has already placed an order of 2 sets of small well completion, and in near future, inshallah, we are going to implement and install this technology in the upcoming wells, and inshallah, hopefully we will be here with a case study, first time in Pakistan on the same farm. Thank you.
Again, first question from my side. In what percentage water production is reduced from smart well completion comparing to conventional completion?
Sir, it depends on it's vary on the well to well. Basically, both zones are producing commingly. So if one layer, bottommost layer, is producing high water cut, so we can shut that layer, or we can even choke back that layer so that the water cut is reduced. So it depends on the well to well.
So it is also applicable in high producing water wells?
Yes, sir, we can install in this, but it is very feasible in the multi layers, so that we can choke down that layer at the bottom, and it so that the water production does not hinder the production of upper layers.
Okay.
Thank you.
Floor is open for questions.
This is Arif Rana from OPI.
Yes,
so how will you test the 5 zones of the well, and then there will be some operational challenges, number of packers passing through the perforation intervals, etc. Secondly, I think there is also limitation about the temperature limit of the downhole gauges. We have worked for the one well at the north. I think it's a limitation. So for the 300 degree F wells, no downhole gauges we can find out. So my first question is that how you will test and then complete for 5 zones you will test and then pass the packer through the perforation intervals.
So basically, the main purpose of ICV is to shut that zone from the bottom. So if there are 5 layers of the reservoirs and we want to close test each layer one by one, we will close the other 4 ICVs of that from that zone and only open one ICV so that we can test only that layer and produce that layer. And at the testing time, all the other 4 layers will be shut in. And the next one is that according to my study, which I have studied till now, that up to 350 degree Fahrenheit permanent downhole gauges are available. Thank you.
Any more questions from the audience?
My name is Zaki Bakhtiar. I have used a lot of these smart well completions in my work experience at Saudi Aramco. So there always used to be a challenge if one of them gets stuck downhole. You cannot operate it. If there's a problem with the control line or for any reason, then they would say that you can operate it using a coiled tubing. You can still go and latch on it and try to manipulate, but it never worked like that. We tried a few times, it never worked. So it will be great if you could understand before installing that what are the possible ways to, in case you have a problem, how would you address them later on at some stage? Like a leak in a control line, if you have a leak in a hydraulic control line, how are you going to address that? So that's just a piece of advice.
Exactly, yes, sir.
So, thank you so much. This couldn't hold back a small thought because I happened to lead the very first Middle East AICD project, and that was a successful isolation which we did and ultimately achieved the multi-layer integration. So you did mention that you're going or planning for smart completion.
Yes, sir.
But it would be good to give us some more insight what exact problem and type of completion you're trying to target, whether you're going for AICD or an ICV, etc. Because I think very rightly pointed out by Aramco folks that it has to be very specific to the condition and environment, and you really have to think through. The other small comment I would like to make is, despite having the DAS systems or downhole temperature and pressure sensors available, it would not completely eliminate the requirement for any subsequent surveillance, but yes, it would certainly reduce that. So you will have an impact on the well cost. So can you relate what type of a smart completion you are considering for Mari gas and why?
So for Mari gas, we are considering the type of ICVs, because I have already mentioned earlier that from ICVs we can control the opening of the choke, and in ICDs we can only we set that ICV at the bottom, and it will only control the type of the fluid. It will only allow the type of fluid that we want, hydrocarbons, and restrict the water production. But in AICDs, if we are getting that production from that specific layer and get the data, pressure and temperature data from that layer, so in case if we think that if this layer need to be choked back to control the water production, then by applying the pressure in the hydraulic control line or electric line, so we can adjust the opening of that ICV so that we can create the optimum drawdown to get the minimized water production and get the maximum hydrocarbon production.
Great, thank you so much and wish you good luck for your project.
Thank you, sir. Thank you.
So the next paper is Integrated Asset Modeling and Field Development of a Gas Condensate Field from Weatherford. And we have presenters Mr. Umar Farooq, Zaid Ashraf, Halim Yusuf, Saad Ahmed, and Chaudhry Muhammad Saqib.
Assalamu alaikum, respected chairs, ladies and gentlemen. I am Dr. Umar Farooq, and I'm a senior reservoir engineer at Weatherford. And today I'm going to be sharing a study we did for integrated asset modeling and field development of a gas condensate field. Next slide, please. So, at the beginning, I would just like to highlight that when we say integrated field modeling, we mean integrated in every sense of the word. We start with the very first seismic survey, and we make our way through to the point of sales, where we actually deliver the hydrocarbons as per contract, which means we start with the GNG survey, GNG part of the study, which involves geophysical interpretation and petrophysical analysis. And then we go to the reservoir engineering part, the classical reservoir engineering part, which serves as the baseline and provides inputs for our dynamic modeling, where we create a reservoir simulation model, and which is then fed into a fully integrated field model that considers not only the subsurface but also all the surface facilities and the vertical rift profiles of the wells. And this constructs an integrated asset model in the true sense, and considers all the uncertainties and all the bottlenecks involved that need to be considered for an optimized field development. Next slide, please. So I'll briefly I will not go too much into the technical itsy-bitsy of every step, but my goal would be to highlight the importance of this study and what value it brings to the field owner, and I will base my talk with that goal. So I'll just start with the brief field history. This is a conventional gas field producing from the massive sands of the Lower Guru Formation. There is a main central reservoir, but the challenge is, again, there is a lot of satellite fields that are kind of scattered around the main central reservoir. And we have conquered this challenge in this field, and we have not only modeled the main central reservoir, but also coupled all the satellite fields with the vertical lift profiles of the wells and the surface network. So this is a brief overview of the field. We can see the cumulative gas production, cumulative water production, the gas oil ratio, water gas ratio, the trends. Next slide, please. So this is an engineering side of paper, so we will just concentrate on the phase 2 and above in that flow chart, meaning all the engineering analysis. So for this study, we went through all the classical engineering analysis, even some which are overlooked and not considered most of the time, such as the rate transient analysis. So we start with the PVT analysis and EOS modeling, and look at the production profile. We go through pressure transient testing. We do rate transient testing as well, where RTA is performed for characterization of drainage areas, and decline curve analysis and material balance modeling for estimating the in-place volumes. So now all these analysis, basically the PVT data analysis gives us the fluid model, which serves an input to any further analysis. And the pressure transient analysis gives us the outputs such as the permeability, skin, and the average reservoir pressure. RTA gives us the drainage areas. Decline curve analysis gives us the estimate for the ultimate recovery of fluids, and the material balance modeling tells us about the aquifer presence and what the in-place volumes would be in the system. Next slide, please. So this is the challenge in the reservoir model was we have a central main reservoir and 8 layers, and then there is a lot of more than 10 satellite fields that are scattered around the main reservoir and are at a distance. So we have created a simulation model for the main reservoir with 2 regions, region 1 and region 2, and 8 sublayers. And then for all the satellite field, we have created material balance models or tank models. And then the most challenging part was to integrate all of these together. How we create the vertical lift profiles of the wells, and we use that to connect all of the satellite field models and the main reservoir models to the surface network, where every single element from the surface network is considered, starting from pipelines, chokes, pressure control valves, compressors, etc. So after a reservoir, next slide please. So we history matched the simulation model, and we ran the initial development scenarios where we considered the workovers in the wells, and we considered infill well locations. So 5 infill wells were recommended based on the simulation model, and we can see, and based on work, the red line shows the DNC, which is the do nothing case, or the base case as we call it, and then the orange line shows workover scenario, orange line shows the infill well scenario, and the green line shows the workover scenario. So we can see the infill wells plus the workover scenario gives us 9.2% increase in the overall recovery. Next slide please. Now once we have created the simulation model, we integrate the model with the surface network, and this is the workflow for us, or the waterfall chart. This basically gives us the importance of why is it important to consider the surface network along with the subsurface. So if we don't consider the constraints at the surface, a lot of the times we know we can see the surface is fluid is being produced to the surface but cannot be injected into the pipeline. So all those kinds of scenarios are overlooked or ignored if the subsurface model is not integrated with the surface. So here the so we take the base case of do nothing, and we take the base case, we add a well, and then the third phase of the coupled model run. By coupled model I mean surface, well, and subsurface combined. The open choke scenario would have been completely overlooked had we not coupled the surface model to the subsurface, and you will see in the later slide how a major impact it holds on the field optimization. And then every successive step, basically we consider the optimized set from the previous one, and then we run the sim. So we go from base case, then base additional, then the open choke scenario, then the stage 1 we run all the sensitivities and select the best out of this suite of solutions, and we take that as the base case for the stage 2, and so on and so forth. Next slide please. So here this is the waterfall chart for the cumulative production of gas. We see the base model gives us 1138 BSCF of gas, and then adding an infill well, basically why we considered an additional well in the coupled model stage was to try to be innovative and see if we could unlock the potential from one of the tight zones in the reservoir with the directional wells. So that was the purpose of including this extra infill well here, which adds 4.1 BSCF. And then we can see, just without any further cost or any major addition to the system, just by operating and optimizing the chokes, we were able to identify a potential of 48.4 BSCF, and that was only possible because it was an integrated study and considered all the constraints of the surface. So basically we can say the open choke, the 48.4 BSCF coming from the open choke scenario is just free gas that didn't come with any investment. And then we considered the front end compression that adds another 203 BSCF of gas, then nodal compression, and the wellhead compression. And for all the compression scenarios, multiple locations were considered for sensitivity, and also the time at which the compression is brought online, sensitivities were run on that as well. So next slide, please. Then doing the economic analysis, we found out that the open choke scenario is very economical, of course, because it's just basic optimization without any or very less maybe investment involved. And then the front end compression adds another 162 BSCF of gas. And the nodal compression, even though we could see it added cumulative volume to the gas, but economically it's not feasible. And the wellhead compression is adding very less advantage to the net present value as well. Next slide, please. Okay, the conclusions here are, again, this is a fully integrated field study, and it comes, I want to just highlight the, the amount of work and challenges involved in this study, as we have a lot of uncertainties in the subsurface when we are modeling, and when we couple that with the surface, the uncertainties are multiplied. We already know a lot of the times the rate data that we get is back allocated, and that is a challenge for optimization of the surface network. A lot of the time pressure control valves are present in the system, but we don't have information on the history of operation of those pressure control valves, and a lot of other issues and challenges we have when we have the surface network, and also combine all the challenges we have from the subsurface. So it's a highly challenging study that we were able to do in a limited time, and the main reservoir is considered along with all the satellite fields, which is not the case in most of the modeling scenarios. Workover and 5 infill wells were recommended. Front end compression was recommended, and further stages of compression were considered uneconomical. And this is the story for this field. Next slide, please. Thank you everyone for listening, and I would like to acknowledge my co-authors and also our colleagues from OGDCL, and that helped us throughout the course of the study. Thank you very much.
Very good presentation. You finished well in time. Again, first question from my side. What incremental recovery you have by optimizing from the wellbore to surface network, all the coupling system from the base case?
So it's the 1138 BSCF is the base recovery, and then the optimization from the surface adds around 250 BSCF to the recovery.
Yes, very good achievement from optimizing the whole system by coupling.
Yes, thank you.
So floor is open for further questions.
Did you calibrated your surface network?
Sir?
Surface network, did you calibrated it?
Yes. We calibrated the surface network based on the data we had from the, let's say, the well tests and the IPRs we got from the well tests. Those were, used to calibrate what we are getting at the surface. All of the surface network. In fact, that's a great question, because that was perhaps the most challenging part and the most time consuming part. When the simulation model was done, and then when we got it coupled with the surface network, the calibration part was very challenging, and yes, it was done. based on the subsurface data and the IPRs we had.
And you also incorporated the compressor performance curves in that matter as well?
The compressors were modeled based as delta P. There was not a detailed modeling of compressors, but the compressors was modeled based on delta P.
Okay, thank you.
Thank you, sir.
Jawad Ahmed from MOL Pakistan. Can you show us the surface network picture so we can exactly see what basically why your FAC was front end compression is giving the maximum recovery? Can you show us the,
Sir, I'm not sure if I'm at liberty to do that, but maybe we can talk after the presentations.
Maybe the distance from the wells were less plant side where this FAC was located.
Yeah, it
basically.
was the distance from there is a main reservoir, and then there is a lot of satellite fields which quite a few kilometers away. So I don't have the exact information, but we can talk after the presentation about those details, sir.
Okay, thank you.
Thank you.
I'm Shahid from PEL. When was this study conducted, and is this field behaving, the way you made predictions? At what stage you are,
It has been quite a few months since it's been completed, and again, I'm not at liberty to say too much, but yes, some of the recommendations we did based on this study have been implemented and showing encouraging results. Yes.
Okay, thank you.
Thank you.
So do we have any last question before we close out the floor? So if none, thank you so much, Umar. Thank you for your presentation, and thank you for a great paper. Thank you.
Thank you so much, everyone. Thank you.
So with this presentation, it's the end of the second session for today. So before heading on towards the third session, it's time to hand over the shields to the authors and co-authors of all the papers. I would request the chair and the co-chair to please come forward for distribution of the sheets. Shields will be distributed as the paper were presented. The first paper presented in the second session was Unlocking the Recovery Potential in Mature Clastic Oil Rim Reservoir Using Integrated Reservoir Simulation Model, a case study in Eastern Potohar Basin. Paper was presented by Saad bin Abrar. Saad bin Abrar, sir, please come on stage for the shield. Sayyid Sharik Ali Hashmi. Muhammad Sarmat, Majid Nazeeb Siddiqui, and Tariq Aziz. In case of absence of any co-author, I will request the authors to please collect the shields. The second paper presented in second session was Smart Well Completions, a comprehensive review of technologies, applications, and challenges. Papers were presented by Mudassir Khan. I will request Mudassir Khan to please come on stage. Muhammad Jahanzeb Ijaz. Imran Shafi. Mateen Haider. Hewad Ahmed. The last paper for this session was Integrated Acid Modeling and Field Development of a Gas Condensate Field. Paper was presented by Mr. Umar Farooq. I will request Mr. Umar Farooq to please come on stage. Halim Yusuf, Saad Ahmed, Mohammad Chaudhry Saqib, Zaid Ashraf. Now I would request Mr. Saeed Khan Jadoon to please come on stage to hand over the sheets to the chairman and the co-chair for session 2. The chairman for today's session was Mr. Zaid Ashraf. The session was co-chaired by Fazan Iqbal.